magistral. Doctor Santoyo, ¿se encuentra? Mucho gusto. Si me permite, daré una breve semblanza de su trabajo, tanto en inglés como en español. De noviembre de 2013 a enero de 2019, el doctor Edgar Santoyo trabajó en la Secretaría de Energía, la CENER como lo conocemos por su acrónimo, del Gobierno Federal de México, ocupando los cargos de Director General de Investigación, Desarrollo Tecnológico y Formación de Recursos Humanos. De igual manera ha sido Director de Innovación Tecnológica. Dentro de los proyectos más relevantes a su cargo destacan la publicación de 11 mapas de ruta tecnológica para el impulso a las energías renovables en el país, incluyendo la coordinación e implementación de proyectos de gran impacto con financiamiento del Fondo del Medio Ambiente y el Banco Mundial para el Desarrollo y Comercialización de Tecnologías de Energía Sustentable. En el periodo 2011-2013 se desempeñó como investigador asociado y profesor investigador en la Universidad de Manchester, en Reino Unido, en donde realizó una investigación aplicada sobre el desarrollo sustentable en la industria, análisis del ciclo de vida y la evaluación sustentable de sistemas energéticos. Actualmente es profesor investigador de la Escuela de Ingeniería y Ciencias del Tecnológico de Monterrey, México. Va en inglés para todos aquellos que nos sintonizan de algún otro país. From November 2013 to January 2019, Dr. Edgar Santoyo worked at the Secretary of Energy, SENER for its acronym in Spanish, of the Federal Government of Mexico, holding the positions of General Director of Research, Technological Development, and Human Resources Training and Director of Technological Innovation. Among the most relevant projects he's in charge of, the publication of 11 technological roadmaps for the promotion of renewable energies in the country stands out, including the coordination and implementation of high-impact projects with financing from the Environment Fund and the World Bank for the development and commercialization of sustainable energy technologies. In the period of 2011 till 2013, he worked as a research associate and professor researcher at the University of Manchester in the United Kingdom, where he carried out applied research on sustainable development in industry, life cycle analysis, and the sustainable evaluation of energy systems. Currently, he is a researcher professor at the School of Engineering and Sciences at the Tecnológico of Monterrey in Mexico. Doctor, bienvenido. Muchísimas gracias por su tiempo el día de hoy. Sin más que decir, el piso es suyo.
Muchas gracias y un gusto enorme. Déjenme compartir mi pantalla. ¿Me confirman si ya la ven?
Perfecto, se ve claramente.
Sí, y la otra pregunta es, ¿se requiere mi presentación en inglés o en español?
Como usted guste y se sienta más cómodo.
Realmente depende de la audiencia. Tenemos personas que requieren inglés, digo, para atención.
Yo creo que sí existe la posibilidad de que sea en inglés para gente de otros países cuando, si están en la llamada o recurran a verla más adelante, va a ser mucho más accesible para más personas.
De acuerdo, clarísimo. Well, thank you for the introduction. For me, it's a real pleasure to be here at this primer Congreso Transnacional de Sostenibilidad y Desarrollo Local en la Península de Yucatán. It's a great opportunity to share my research, and a special thanks to the organizing committee. They have been very cautious with all the details, and with a special thanks to Dr. Ali Bassam for inviting me. So the title of my presentation, as you can see, is the Sustainability Assessment of Renewable Energy Technologies. It's more a summary of the work that I have carried out, but more to promote this type of integrated methods from a systemic point of view for research applications. So the content of my presentation, more or less I will be covering what you can see on the screen, and I'll try to adjust to the time available as much as possible. So first, I would like to start with this question: what is energy systems integration? Why this?
Doctor, I'm so sorry to interrupt you, but your PowerPoint presentation isn't viewable anymore.
It's not? Okay.
No.
Sorry about that. I'm more used to using Zoom.
It's okay, it happens.
It got disconnected. Well.
Okay, now it is visible. Thank you.
Now it's visible. Thank you. Thank you, Sabrina. So why is this important? Usually, especially in the energy sector applications, the trend is that the different researchers across faculties, disciplines, we specialize, or we try to specialize in one particular topic or technology. But the important thing, and what I have learned from my experience in government especially, is, and of course in my research, is that we have to use aim for a systemic approach or a holistic perspective, or where what the work we're doing is connecting to other dots or other clusters across the different disciplines and research. So what is energy system integration? The definition is there. So it's basically how can we connect all the energy supply and demand sectors. What is the role of the energy carriers? What is the role of the energy technologies? And the better we can understand these connections and this network across the energy technologies or energy systems, the better we'll be able to understand if what we are doing is relevant or not, or how relevant it is to the field under study, especially if we're talking about sustainability. So this is a slide from the International Energy Agency. As you know, this is one of the main actors worldwide for the energy sector in terms of promoting energy, a better energy planning, a more sustainable energy system to promote public policies. So basically what we can see here is that we will have to integrate these different components. In the left part of the screen, we have primary energy. As we know, fossil fuels dominate the industry, but renewables are gaining and gaining more weight or more importance in this field. And of course, renewable energy, a few years ago, decades ago, we had the wrong idea that this type of technologies were completely clean and just substituting the fossil fuels. But the answer is not that simple. Even renewable energy, which I promote very much in this application and research, we still need to work on improving our assessment and trying to improve as well the technologies across their life cycle, even more in a context of more limited resources for minerals, materials, metals that will be required in order to produce the technologies that we need in the different end uses. And if we follow the diagram, we will have the conversion sectors, of course, power plants, refineries, heat generation, that again, these conversion sectors dominate the industry. And they are the main sources to produce the secondary energy, which is electricity, all the oil products, gasoline, diesel, among others. And also how we can understand the efficiencies of the industry at the end use part or stage, where we have industry, buildings, transport, and the end use service demands related. Of course, mainly is electricity, heating, cooling, and mobility. So keep this thinking or this approach in mind in order to better understand what the proposal of the framework is presented in this work. So this is, as far as I know, the most recent publication of the IEA, the roadmap for the global energy sector. So what we have here, we have the key clean technologies round up by 2030 in the net zero pathway. So these are things that are already happening, and the trend is going to be even more intensive in terms of the penetration of these technologies. So in the case of solar PV and wind, we expect an increase of 4 times the current capacity to be able to reach up to 1,000 gigawatts. But it's not only the important change. If we understand the energy system thinking approach, then we will see that the supply and demand, they will always be connected. So if we are aiming to have more electric cars, as we can see from the slide, and this is already something that is happening, especially in the developed countries, where the energy transition from conventional combustion engine is going towards the hybrid or electric cars. In Mexico, we're still lagging a bit behind, but I think that in the following years, the increase will follow this type of trend. But the important thing, the question would be, what type of electricity we will be providing to our electromobility if it's coming from more carbon intensive sources, or if it's coming from renewables such as solar PV and wind. And of course, something that is good news for everyone, and if all the countries are committed, then we will see a decrease in the energy intensity per unit of GDP produced in about 4% per year, which is, as I mentioned, quite important in terms of energy efficiency, which is the low-hanging fruit when it comes to energy transition. So what is another key aspect or key remark regarding this publication? Clean energy innovation must accelerate rapidly, with governments putting R&D, demonstration, and deployment at the core of energy and climate policy. This I would like to highlight because it also comes from part of my experience at the Ministry of Energy. As you listen, I worked there for a few years in the last administration, and one of the key aspects was to be able to do better energy planning, strategic planning for the country, in order to strengthen the capacity building for the country, so we could leverage a more sustainable supply chain of different technologies. That was the objective, that was the aim. There was a lot of work carried out. There were two specific funds which were administered by the Ministry of Energy, which was the Energy Sustainability CONACYT and Hydrocarbons Fund, that were aiming to be able to to comply with these goals. And I could say that from my point of view, we did a relevant work aiming for these type of objectives. But the important thing is not try to do it once in a lifetime or just to have isolated efforts. The importance is that we should continue these efforts in order to see the results in the short, medium, and more importantly, long terms. Unfortunately, as we know, the policy in Mexico currently, nationally, has changed quite a lot. It has changed quite drastically. So we need to bring back the decision makers and the discussion among academics, policymakers, industry, and society in general, that we need to go back to a more sustainable proposal, where we can see better standards in terms of environmental policies, better standards in terms of energy efficiency, and that these type of efforts would require not only public policy, not only regulation, but also massive or important investments coming from different parts of the productive sectors. What else can we take from this report is that by 2030 and beyond, most of the annual CO2 emission savings, because we're talking about the net zero pathway, what this means is that we will try to decrease the emitted CO2 emissions on greenhouse gas emissions, so we'll be able to balance these emissions in the atmosphere. So most of the emissions will come from technologies already in the market. That doesn't mean that these technologies cannot improve. They can always improve, especially if we're considering energy indicators or circular economy indicators. But another important data which you can see here is that technologies that have been developed, that have not been developed, or they are currently under development. If we look at hydrogen, mobility, heat, electricity sources, the main savings or the main decrease in this carbon footprint of technologies will come from 2050, according to these projections. As far as we know, this will stand in this trend in the developed countries, but we cannot say the same for the developed countries. So we need to get everyone into the discussion so we can have a clear roadmap of what the future energy system would look like in case of, in particular in case of Mexico, you know, and the different regions. The key milestones in the pathway to net zero, I like a lot this slide. We can see the emissions in gigaton CO2 according to the different sectors, considering the energy system sector, which is divided into buildings, transport, industry, and electricity and heat, as I mentioned. So here we could see a clear roadmap from the publication with the horizon of 2030, 2035, 2040, and 2050. of course, there's a lot of information shown in this graph, but I would like to highlight that by 2050, the ambition targets, as you can see, is that we will require more than 85% of buildings already zero carbon ready, more than 90% of heavy industrial production to be low emissions, and almost 70% of electricity generation globally coming from solar PV and wind. Of course, this is at the global level, and the countries will need to do the energy planning transition exercises to see whether, if they have similar targets, more ambitious or less ambitious, depending on the demands of each country. So, what is being proposed and what has been my main role in terms of research, and these efforts I have also not only applied them in academia but also in the government. So it's to be able to combine this energy system thinking approach with the sustainability assessment framework. What is this? We will have cross-cutting research methods, and I'm sure that you have heard many interesting talks of experts in many fields and technologies regarding the energy and sustainability. So I've been working in several sectors, as you can see here: indicators, life cycle assessment, techno-economic assessment, technology roadmaps. But it is important that if we have a lot of information, a lot of research going on, what would be the second stage of that analysis or data or all the inputs of information is that we need to be able to integrate all of the information using some methodology called, in this case, multi-criteria decision analysis, so we can understand the interrelation of this information, the interrelation of these stakeholders, but more importantly is that we be able to give a clear message of what the main results, conclusion, task, milestones will be able to provide to the decision makers to have better decisions in the future. So in terms of research themes, I've also worked with energy system analysis, industrial ecology, sustainable mobility, and of course, as the main purpose of this talk is the renewable energy and low carbon technologies, I will show some of this work methodology applied to a particular case studies. And because now today all the discussion is around the United Nations Sustainable Development Goals, of course, as researchers, as stakeholders, we have to be able to see where our research is connecting and whether it is providing something positive, something constructive to these sustainable development goals. And particularly, this talk of today will be focused more on the life cycle assessment. As a result of this research, I can say, and I'm very proud of course, is that there was a recent bibliometric analysis and review carried out by these researchers in Spain. And the surprise was that they carried out an extensive research from 95 to 2020, more or less, analyzing more than 4,000 publications. And they classified this sustainable energy assessment in different clusters to see what were the trends, which groups of researchers were working in different fields, and what has been the impact of this research. So in summary, we can see here the map of the different countries working on these areas. There is a clear leadership, and it's not a surprise that is shown by the US, followed by others such as China and India. Europe, Brazil is doing quite a lot of work as well. But we can see there that there is one, let's say, specific study that is making an important impact in this field. And it's important to highlight it, not to show off. That's not the objective. The objective is that we are able to do high impact research in different fields. But the important is that, again, it doesn't stand just an isolated work or research. The important thing is that we can promote more human resources training, more work, collaboration work with students, with other researchers, so in order to have more studies like this. So in summary, this is the study. This is one of my main publications that I have developed. By the time it had that number of sites, today it has more or less double. And the work has been quite relevant in different discussion themes around the sustainability. As you can see, the life cycle analysis, the multi-criteria decision making, renewable energy sustainability, among others. So this is the paper. Now it has more than 500 sites, and we hope that the number is increasing. Of course, it doesn't depend on the authors. It depends on how useful the community, research community, will find the work. And the challenge for us now is how can we continue with similar studies, similar trends, so we can aim for a similar impact, right? So in terms of this study, there were many objectives. This was the first study of this type, especially aimed for Mexico. But the interesting part, you can see here the objective, is that when I finished the work, there were many different novelties that were highlighted as outcomes of the research, that they could be used for other applications, and these could be used for other countries, other sectors. So to be able to replicate the research, I think, and that other countries find it useful, or the authors, I have had sites from all over the world, including the US, UK, Japan. So the important thing, again, the message is, how can we make sure that this message goes to more people and we're able to do better research from a multidisciplinary perspective? The framework, in summary, is not that complex. Of course, the framework is aimed to try to analyze and to recommend decisions for complex systems. And the methodology, it's as we can see schematically here, is quite simple. No? We would have a stage of indicators, the definition of indicators, the definition of technologies, and then to be able to assess each of the pillars of sustainability, from the environmental, economic, social, and then from the different, let's say, indicators and data availability that we have, then we can have the development of the scenarios, and at the end, to carry out a multi-criteria decision analysis for better informing about the main findings of the work. And also, as a result of this research, there were other two related publications which combined, they more or less have 250 citations. The first one, the paper in the top, it was, as far as I know, the first life cycle assessment study for the power sector in Mexico from a systemic point of view. And the second paper below, and it's always also, I think it's quite relevant. Now we're talking about decarbonization and net zero emissions. It showed the first decarbonization scenarios of Mexico for the future, for 2050. And by the time the discussion of 2050, it wasn't that common, at least for Mexico, for the country. But nowadays we can see that it's one of the main horizon discussion points in this type of conferences. And of course, I just have here a summary of the main results, but you can see here the number of scenarios that were analyzed and also compared to other available scenarios. At that time, it was only the International Energy Agency, which developed one scenario for Mexico, business as usual, and also Greenpeace International, which also developed a complementary scenario. And my task was to be able to compare those, to monitor, or let's say quantify, their sustainability indicators, and to be able to compare them with the rest options that could be feasible for the future. And I won't go into the details of the data because it's quite specific, but this is just one example of the complexity of not only the system that we can analyze, but also the options or solutions we can have. And sometimes when you have many solutions, it becomes very difficult to give a clear message of what is the right roadmap of pathway to follow. So that is the challenge. And in terms of LCA, I don't know how much do you know about LCA in terms of this forum, in terms of the people that that is currently present in this conference. Is basically a methodology which aims to assess the environmental sustainability of products, technologies, services from the raw materials extraction and across all the life cycle perspective. That includes the transport, manufacturing, distribution, the operation, and in some cases, the end of life. The end of life has become even more important nowadays, because not only because of the negative implications that we could have if we continue business as usual, but also of all the opportunities that have arisen from the economic perspective, environmental and social aspects as well. So this methodology will aim to quantify all the flows or carriers, the environmental energy carriers as inputs and outputs, and to be able to estimate the environmental impacts that in turn will give us an opportunity to improve the technology, process, or system from a holistic perspective. The LCA framework is mainly classified in 4 stages, which is the golden scope of definition, which is very important, and it has always to be revised. Inventory analysis, which is the most time-consuming of the work, and the impact assessment, which also has its own stages or steps to be able to assess this part of the work, and the very, let's say, fine work that it has to be with the interpretation of those results, which can have many direct applications. It goes from product development and improvement, which now is getting even more attention, especially from industry in developed countries. I hope that I can see this trend very soon in the coming years in Latin America, in countries like Chile, Mexico, Brazil, Argentina, and also in public policy making. From the profile that I was read by Sabrina, you could listen that I was responsible of this, developing the first national roadmaps, technology roadmaps for renewable energies in Mexico, of course, in collaboration with not only with CENER, but with many actors, academia and industry. But important here is that each of these roadmaps, that the good news is that they are still available at CENER in the Ministry of Energy page, web page, is that as one of the key aspects, it highlights that life cycle assessment of the life cycle perspective will be required, will be essential to map a better or more sustainable supply chain for the different renewable energy technologies, just as one of the examples, right? So in terms of the applications, and LCA has been applied in the web, in the academy work very widely. You can see now LCA almost everything, and especially in more developed countries, you can find a huge number of this type of studies. But it's not the same for the developed countries or Latin America. We're still developing this type of relevant studies. We're still developing capabilities, but the clear message here also is that we need to do even more. And in this part, I would like to talk about 2 very brief examples, the case of the thermal energy. Here we carried out just a couple of years ago this review just to be able to understand the state of the art of the LCA application of the thermal power generation technologies. And I could say that this work has also been quite relevant, and the impact has been increasing over the years, and we hope it continues that trend. But the most important message that we can get from this work is that we need the multidisciplinary approach as well to be able to get better LCA studies. I consider myself an expert, or I aspire to be an expert of the life cycle assessment methodology and application, but to be able to model these systems better and to propose improvements from the environmental sustainability or energy perspective, we also need the experts working in the different fields, in the operation of the plant, in the construction, in the exploration part, in the end use of life. So it's a way of validating this type of improvements, but also it will give us a lot more certainty of what we are proposing to the community. So I won't go into detail in this part. I'm not an expert of the thermal energy, but I understand why we did this type of study. The thermal energy has a huge potential in terms of providing electricity and heat for both Mexico and worldwide. And Mexico has a special potential for that. Currently, it's, I think, the 6th installed capacity and generation worldwide. And again, the purpose of applying LCA is not only to identify where are the main environmental hotspots, but according to the new technological innovation trends, where those technology innovation can add to the life cycle of the technology, and whether these alternatives or part of the solutions will be more sustainable if we consider the whole supply chain, because sometimes one solution can look more promising if we consider just one criteria, but when you consider the assessment of multiple conflicting criteria, then it won't be that easy to see whether that alternative is being the most preferred for the system. And like I said, the important message here as well is that in case of the geothermal power plant, we need to consider the exploration part, the construction, the maintenance, the operation, and if possible, and depending on the characteristics of the geothermal power plant, we'll be able to include the end of life or even to map the circular economy opportunities across the life cycle of this technology. What we found is that some of the outcomes of this work is that there are huge differences in terms of the results, in terms of the carbon footprint. It could be according to the technology, it could be according to the type of fluid used, it could be according to the lifetime, to the operating conditions, to the operating standards. And so if we have that type of variety for this work, of course, if increases the complexity of the systems, but again, the aim is to be able to integrate all these aspects so we be able to improve them for the future. And here we can see the carbon footprint results for different type of geothermal power plants, such as dry steam, single flash, double flash, binary cycle, and that these different works have been mainly published for developed economies, such as Japan, USA, Italy, and some others that are quite doing a relevant work in terms of producing the first studies for the countries. So in case of the solar photovoltaic, as we heard from the introduction, this is going to be one of the key technologies to be able to supply the energy demand for the future at the global scale, but also in Mexico. Mexico is one of the top countries globally in terms of solar energy. We can use, as we know, we can use solar energy to convert it for heat applications if we use the concentrated solar power or the solar thermal route, or we could produce electricity if we use the solar photovoltaic. And from the energy reform that was proposed from the previous administration, we have seen an increase in terms of the solar PV system installed in the country, especially for residential and commercial applications, because it's not only a sustainability decision by the customers or the households, it's also good for their pockets. It's good for the economic perspective. So also we thought that to be able to do a first LCA study for a grid-connected multicrystalline silicon photovoltaic system in Mexico will be important to highlight the importance of these type of methodologies for these systems, because we need to start to producing better information, better energy sustainability information to take better decisions. So in the future, we don't only become importers of technologies, and we won't have a clear idea what is happening with the value chain of that technology, but we will be able to integrate, instead of that, to integrate the different productive value chains so we can produce this type of PV systems in the country with better sustainability conditions. And this is quite recent work. It started to get the citations, of course, the sites, and the most important here is that in this work we highlighted as conclusion and key remarks that we need to use this type of study to improve the technologies, but also to improve the public policy, the regulation, and the strategic planning for the country for the next years. In terms of the life cycle of solar PV system, we have considered these main stages, which is the mining of the raw materials, the production of the solar PV system modules or cells, the balance of system, the operation of the PV, and some considerations for the end of life, which is, I could say, is one of the key aspects or hotspots that we still need to do more research, get better data, and improve the results regarding the whole perspective of the solar PV system. And this is how we have classified, and this is in line with a lot of the work that has been currently done, for example, in the US by the National Renewable Energy Laboratory. They have been in they have been carrying out state-of-the-art research, not only evaluating the LCA and the energy aspects of the solar PV systems, but also trying to understand a bit better what is the complexity of this supply chain, and as well, what are the economic and social implications of using the conventional materials or if we are aiming to use new materials, or let's say novel methods for the conversion of materials, then we still need a lot of research to carry out to be able to do this in a more feasible and sustainable way. So for the results, of course, there is no surprise. We find a few things that are quite interesting. We need to work more about the improving the production of the solar PV systems, but still there are other components such as the inverter of the solar PV system that also has some significant impact, and perhaps there will be another scope of the study to be able to improve the whole the integration of the different parts and components to produce the energy systems. And here we can see an energy Sankey type format diagram where we highlighted three of the main impacts that I think it's important to mention: the global warming potential, the human toxicity potential, because there are a lot of course, of components that add negatively to this type of impact, and the impacts that also affect the aquatic or the marine ecotoxicity aspects or categories. And just to close this part, another conclusion, or let's say key remark from this research, is that it's good that the different countries are already using and producing a vast amount of solar PV system. These have been installed across the world, but very few countries are thinking about what is going to happen with all that installed capacity when the solar PV systems reach their end of life, which could be 20 years, 25, or even 30 years. So even though today we consider solar PV a clean technology, which I explained depending which stage of the life cycle we are analyzing, we still haven't thought what is going to happen with all the residual or the toxic compounds that will go to landfill or other type of waste management. So the key message is that we need to start planning for a better way of integrating these aspects into future studies that will be able to address the sustainability aspect of these technologies. Just an example. This is not a criticism just for solar PV. It's a constructive criticism. Of course, renewables are better, always better, preferred than fossil fuels. That's not the question or the remark we're doing here. The thing is that all the technologies such as solar PV, wind, geothermal, bioenergy are not perfect. They are not ideal. So we'll need to work better using these methodologies to be able to aim for more sustainable low carbon energy technologies to meet the demand of the future. And Mexico should be already thinking about this task, as the US, Japan, Germany, and other leading countries are already producing these type of studies. And for the conclusions and key remarks, sorry about that. I just highlight what you can see there. I'm not going to repeat everything, just the last part. To be able to address the sustainability or the complex issues regarding sustainability that we have today, such as the Sustainable Development Goals, we will need to improve on the frameworks, the research, and to be able to include more multidisciplinary, transdisciplinary aspects so we can train better the new generations of engineers, students, technicians, entrepreneurs, politicians, regulators, and other relevant stakeholders with a sustainable thinking. And with that, I would like to close my presentation. I hope it was the most clear as possible. And here you can find my email in case of you would like to contact me or you're interested in any of the topics or papers that I presented today. Thank you.
Well, thank you very much for that amazing presentation. I'm sure everyone has a lot of questions because I see many already on the chat. So if you allow me, I'll start with the first one. Do you think Mexico should use more geothermal energy or just keep looking for solar and wind power?
That was a similar question which I did myself when I was doing my PhD, and I still did it when I was at the Ministry of Energy. I discussed those type of things with my team, and I think the most important is that there is no one technology that is going to provide the solutions or all the energy that will be required. So we need to focus. We need to focus on better identifying the energy mix, the technology mix, the optimal that will be required in order to optimize the resources of the country. So, yes, we need to use more geothermal energy. We need to use more solar, wind, and the other available that we will have, because also in the case of Mexico, which is always try to support that we can do the best with what we have, is that Mexico is very rich in all these resources, and it's also very diversified across the country, across the regions. So we need to analyze what is the potential in one specific region, and if we're able to connect those resources with other regions and to optimize the network to be able to have more sustainable and as well as reliable and cheaper electricity or energy for everyone.
Yeah, exactly. It's a combination of everything. But well, the next question is, thank you very much, Dr. Edgar, for your extremely rich keynote speech. I am sure that your professional experience and your academic career is a heritage to be promoted and invested in for the well-being of energy in Mexico. Today, a great question arises from the paradigms that characterize renewable energies, social resistance, active movements, among others. The question is technology an ally or an enemy of sustainability?
These are very philosophical questions, but very interesting. And in fact, this type of questions is the one I discuss in my undergrad courses at Tec de Monterrey, especially with the sustainability development courses. If you know, there is one famous equation, which is IPAT, no? Which is basically it relates the environmental impacts with the population, the affluence, and the technology aspects. So what it tells us from this equation is that technology is the best alternative that we have to be able to use it for our advantage. Let's say that depending on the application or the specific technology can be an ally. Of course, if we're talking about energy and we're aiming to decrease the energy intensity or carbon intensity, the limit of the technology will be more the thermodynamic limits of the efficiencies, the availability of the materials, the commercialization of the technologies. But if we be able to improve all in those aspects, we have a positive consequence towards for the environment, for the ecosystem. Of course, what I'm saying is that not everything will be, let's say, a direct question. We will need to assess and to evaluate from a life cycle perspective whether if option 1 is better than option 2, whether if carbon capture and storage is a good decision for specific conditions in the industry sector, or we will need to look at other options that could do better in some selected indicators. But yeah, I think the question is that technology can be used both as an ally, or it could not that much if we don't, let's say, optimize its potential.
Yeah, I think that's a never-ending question and theme of debate, but a really good question from your part. Another question is, does Mexico have any regulations and protocols on the end-of-life management of renewable energy systems, including batteries, solar panels, wind systems, solar thermal, and geothermal systems?
As far as I know, there were some aspects included in the previous regulation, which is, I think, still is available, the Energy Transition Law and the law for electric industry, when they talk about externalities. But I think we still need to be more specific in terms of what would be the standards, what would be the methodologies, who can certify, who can validate, who is responsible at the different validation stages. And as far as I know, we don't have at the moment a clear public policy document or regulation that specifically clarifies all of these questions that we have today. I've heard recently there is a discussion of a circular economy law, new law. I don't remember if it's in Mexico City or if it's at the federal level, but that would be a good start, right? To say what would happen with the end of life, not only about energy, in terms of packaging, in terms of everything that we can think of in terms of food, agriculture, health, disposal, etc.
The following questions are in Spanish. I'll read them in Spanish and then translate them in English, okay? Gracias por su conferencia tan enriquecedora. Me gustaría hacer las siguientes preguntas. ¿Cómo podemos saber qué método de evaluación emplear al realizar un LCA y cuáles categorías de impacto considerar para nuestro análisis? Y segundo, ¿cómo se define que un método sea más adecuado que el otro? Ahora en inglés para todos aquellos que no nos entiendan. Thank you for your conference. So empowering. I would like to make the following questions. How can we know which method of evaluation we should apply at the moment we realize an LCA, and which categories of impact we should consider for our analysis? And secondly, how do we define which method will be more appropriate than another?
Sí, también aquí, bueno, contesto en español esta parte, y es importante esto mencionarlo porque hoy en día se ponen de moda los conceptos, ¿no? Y la gente a veces empieza a utilizarlos de manera más trivial e incluso te encuentras papers que hablan de life cycle assessment, pero cuando empiezas a leerlos realmente no entiendes qué metodología ocuparon, qué alcance, qué etapas, qué indicadores. Yo recomiendo que se siga lo que presenté ahí en el slide, el ISO estándar, que es el 14040 y el 44, que sigan esas 4 etapas de las que mencioné, para poder entrarle a un estudio de este tipo, que no va a ser trivial, como dije, tampoco es lo más complejo del mundo, por supuesto que no. Un LCA es un ingeniero, un economista sobre todo, ingeniero economista lo pueden entender muy bien por las bases que se tiene, y aquí lo importante es saber entender muy bien el sistema y acompañarlo con el enfoque multidisciplinario, ¿no? Es decir, si yo me hago experto o practico mucho más en modelar el CA, pero yo quiero hacerlo sobre diferentes aplicaciones, pues sin duda no voy a saber. No somos todólogos, no vamos a ver los detalles de la aplicación y para eso hay que acercarnos. Bueno, si en este caso queremos hacer algo de tipo energético, voy con tal persona. Si quiero hacer algo con la parte de biotecnología, voy con tal expertos. Igual de los metales, de la parte de todas las posibilidades que se tengan. Y también los impactos ambientales, habrá algunos que significan algo o mucho para ciertos actores y otros no tanto. Creo que el más común es el de la huella de carbono, el Global Warming Potential. Yo creo que ese, en gran medida, pues todos los actores lo entienden bien, pero después hay que ver cuál de estos métodos, porque los estudios del CA robustos van acompañados de bases de datos también bastante robustas, que generalmente los traen los softwares comerciales. Estos softwares comerciales, que son el Gavi y el CIMAPRO principalmente, traen ya unos impactos ambientales precargados que son muy variados y que se los están actualizando todo el tiempo. Entonces es difícil también estar al día con todos esos detalles, pero lo que sí es la mayoría de esos métodos de impacto ambiental que siguen una metodología de caracterización, clasificación y al final tener 2 tipos de impactos, lo que se conocen como midpoint o endpoint categories. Ahí el análisis es qué es lo que queremos, qué es lo que queremos informar, entonces por cuál método nos vamos a ir. Generalmente estos métodos están siendo desarrollados por grupos en Europa, Japón, Estados Unidos, algunos ya más regionalizados, pero creo que es una área de oportunidad para América Latina o economías de desarrollo en que trabajamos mucho más en este sentido. Pero como dije, no me voy a casar con un método, una herramienta específica. Hay bastantes y sí conozco varias, pero lo importante es cuál es el enfoque del estudio para poder hacer una recomendación más específica, ¿no?
Perfecto. La siguiente pregunta es, bajo su experiencia como funcionario en CENER, en su opinión, ¿cuáles son las razones del por qué no hay una normativa obligatoria en materia de reciclaje dentro de los sistemas de energías renovables? Va en inglés. Under your experience, under functionary inside the CENER, in your opinion, what are the reasons in which there isn't a mandatory norm for recycled material within the renewable energy systems?
Sí, yo creo que aquí un poquito lo que nos pasa en el país a veces es la diferencia con los países desarrollados es que nosotros actuamos a veces en consecuencia a algo que ya pasó, ¿no? O que ya vemos, mientras que los desarrollados tratan de ir un paso adelante para prever las condiciones o problemas que puedan tener en el futuro. Y eso creo que es algo muy común en nuestro país, ¿no? Lo importante aquí yo creo que es una industria todavía bastante nueva, es una industria que se está desarrollando. Tenemos algo de información, pero la información disponible de las cadenas de valor no son tan visibles o no son tan accesibles como en otras partes del mundo, ¿no? Donde hay observatorios, bases de datos públicas. Aquí como que siempre tenemos que ir un poquito arrastrando, ¿no? A contracorriente para ir buscar los datos de diferentes dependencias y que tengamos todo en una misma base de datos. Yo creo que esto debe ir evolucionando, quitando un poquito el cambio de política tan drástico que se ha tenido. Yo creo que es una área de oportunidad para que México pueda tomar liderazgo en esto, en América Latina, sobre todo, ¿no? El decir, cómo podemos planear que para el futuro no solo el consumidor empiece a pensar en estas cosas, el regulador, pero también las empresas que te ofrecen el servicio. Un ejemplo lo voy a poner con los carros eléctricos, ¿no? En México. Hoy en día ya hay varias marcas que los ofrecen. Los carros eléctricos, los carros híbridos, ya son carros comerciales, ¿no? Que se están vendiendo en muchas partes del mundo. Pero yo les preguntaría, ¿ya se tienen, una vez que termina el ciclo de vida útil de las baterías de esos vehículos, ya se tiene pensado qué va a pasar con esas baterías cuando ya se tengan que reemplazar, o el módulo, ¿no?, de la batería? Entonces, hay ciertas cosas que en el ecosistema de innovación o innovación tecnológica tienes dos secciones, que es el Technology Push o Market Pull. Algunas cosas pueden ser empujadas desde el punto de vista de qué objetivo que hemos visualizado, una tecnología que va a contribuir a un sector específico su uso, entonces tenemos que ver cómo empujar eso con toda la cadena de valor. Y otro es el que te va a regir también la parte del market pool, que el mismo mercado te lo va a exigir con la regulación, a veces no interna, a veces externa, en donde le pidan a las empresas que parte de sus piezas vengan con ciertos estándares de huella de carbono, o con ciertos estándares de economía circular, o con ciertos estándares incluso de ciclo de vida. Entonces, donde la integración de cadenas de valor va a ser muy importante. Nuevamente, regresando a la pregunta, a mi parecer todavía México no cuenta con esas perspectivas, o por lo menos primeros documentos de discusión, pero por favor los invito a leer ese paper que publicamos. Ahí viene parte de esos mensajes para que empiecen a detonar esta discusión y tengamos más avances en esto, espero, en los siguientes años, ¿no? Como comunidad y como país.
Bueno, y una última pregunta. ¿Crees que los sistemas de energía basados en hidrógeno o los sistemas de energía basados en electricidad son el futuro? Repito en inglés. Do you believe that energy systems based on hydrogen or electricity are the future?
Nuevamente, ¿no? Dependiendo desde qué punto de vista lo veamos en el Energy System Thinking Approach, el que les presenté, y también de qué aplicación end use estamos hablando, ¿no? Si hablamos del sector transporte, por ejemplo, es claro que, bueno, además es uno de los sectores más contaminantes a nivel mundial, y en México no es la diferencia. Ahí es una gran demanda de energía y de uso de usuarios y de tecnologías. Sin duda no lo vas a poder hacer con una sola tecnología o tecnología otra vez. O sea, electromovilidad no va a ser la solución absoluta. ¿Por qué? Porque todavía esa tecnología es costosa, porque también qué tan bueno va a ser un carro eléctrico, pues va a depender de la energía que le estés cargando, ¿no? Como mencioné. Y lo otro es, vas a requerir infraestructura para una u otra tecnología. La infraestructura, por ejemplo, de electromovilidad, pues hay ahorita algunos ejemplos y casos en las principales ciudades del país, pero eso no te resuelve una decisión de decir, ahora vamos todos a una política de electromovilidad. Entonces, ¿en qué casos, así como el de hidrógeno, celdas de combustible, bioenergéticos y otros, sin duda tendrán su nicho, pero hay que evaluarlo, hay que evaluar cuáles son las opciones más viables? Nuevamente, es un sistema complejo, por eso es que no es una respuesta inmediata, depende del caso de estudio. En el caso de hidrógeno, yo recuerdo cuando estaba haciendo mi doctorado, hubo un auge tremendo, todo el mundo hablaba de hidrógeno en muchos lados, de pronto fue un tanto sigiloso ya hace pocos años empezó otra vez la discusión del hidrógeno, ¿no? Sobre todo en países como Alemania, como Japón, donde ven un gran potencial para varios usos, pero nuevamente hablamos de países que ya tienen cierto base, plataforma de infraestructura y de evaluación, y ahí veamos las opciones, analicemos el proyecto, el sistema, y con eso tratemos de obtener los principales elementos con esas herramientas que podamos calcular para entonces tratar de tomar una decisión que pueda aportar a la mayor cantidad de indicadores o los principales intereses de los actores en la cadena de valor.
Muchísimas gracias. Haré una entrega oficial, si ahorita pueden ver mi pantalla, de su constancia de participación en nombre de todos los organizadores del evento en general, de aquellas asociaciones y organizaciones que han apoyado el evento. Muchísimas gracias por el tiempo que nos designó el día de hoy, por todo el conocimiento, al aclarar dudas y al presentar toda su información. Muchísimas gracias. Un aplauso enorme y un abrazo hasta Monterrey.
Muchas gracias. Yo estoy ubicado en Campus Ciudad de México.
Ciudad de México, entonces.
Aquí tengo mi base, y la verdad muy contento por la invitación. Muchas gracias, Sabrina, excelente moderadora. Y también muy contento en seguir fortaleciendo y buscar muchas más colaboraciones con su universidad, ¿no? Y con Yucatán. Ha sido un gusto. Gracias.
Muchísimas gracias. Creo que hasta aquí haremos